Sure. Okay, so I just want to briefly mention a couple of more interesting applications. I hope you like the ones I showed so far. So this one is lip reading, and I mentioned this briefly, and let's just take a look at the video.
Place blue in M1 soon.
So you can see here that the network takes as an input this image and figures out where the lips are and just crops that region, and then figures out what the person is saying just by looking at these lips. And how the network was trained, it was trained in a supervised learning fashion where it saw a lot of lips and knew exactly what the person said in maybe in textual format, and that's how you train these models. You show them a lot of examples, input output, and it learns the pattern. So that's one example of understanding humans. There is this one that's really interesting. It's kind of, you try and figure out the pulse directly from video. So let me just show you, it's easier.
We automatically select and amplify a narrow band of temporal frequencies around the human heart rate.
So this is not fake, this is totally real. So you can use this to, for example, monitor babies, and it works really nice. They actually compared it to state-of-the-art devices that are really pricey and expensive medical devices, and this one works really, really decently, similar accuracy. Surveillance, okay. So this one may sound Orwellian, but there are many nice applications. There are, of course, always a lot of questions that we as a society need to answer, but there are many cool applications that can be done here. So, for example, is tracking traffic, and if you know what's happening in the traffic, you can improve the traffic. You can optimize. You can save people some time, and that's an awesome opportunity, right? So also detecting theft in retail. That's something that big retail companies like Walmart want to invest a lot in. And you can maybe imagine like a camera on a swimming pool. If a victim is drowning in the pool, the camera can automatically detect that and maybe ping the guard or somebody, and you can save lives. So there's a lot of beneficial things. There's a lot of bad things that can happen if this is not used in the as any powerful tech, starting from nuclear energy to computer vision. Everything can be used for bad or good. We just we want to make this used as a good thing, but it's a constant fight, right? So also, if you haven't tried this one, this is really cool, and it's also powered by computer vision. So basically, everybody knows about Google. So you're usually querying the search engine using textual inputs. You can actually query it using images. So I used this one once when I wrote one blog, and I just went to Google, as many people that don't know anything about copyright, and Anya will probably laugh here, but I just went to Google, Googled random image, took it, placed it on my blog, and then when I figured out, hey, there's this copyright thing, I just went and I just searched by this image, and I figured out the exact moment when the image appeared on the internet, and I saw that some artist had uploaded this image to Shutterstock, so I went and bought the image. So this is really a useful thing to have in your toolkit. Google Earth, where a bunch of Google cars and airplanes are flying around the Earth, and they pretty much created a 3D reconstruction of Earth, and you can use it in a bunch of different ways. So one example here is to track deforestation, and this is really useful, like as a health monitor for our planet. Basically, you can see here in 2001 the reconstruction that they captured, and as you move toward 2013, and I don't see the number here because of the chat, but yeah, you can see that deforestation is really severe. I guess this is Amazonia or something, but yeah, so there are many cool applications for this also. Biometry, I mentioned iris recognition. When I mentioned HoloLens, you can also extract information from fingerprints. You can use human face as a unique identifier, although this one is a bit worse. So iris is something that's pretty much stable throughout your life, as well as fingerprints, not so much, depending if you're maybe some manual worker, you may even lose fingerprints, but like iris is pretty stable. You can also use gait or the way somebody walks to figure out who the person is using only cameras. OCR is another really interesting application. So a couple of years ago, I was like, hey, wait, but I mean, I already see the text here. What's the thing? Well, the thing is that cameras only see matrix of numbers, and you want to figure out a way to extract this text and convert it into textual information. So you can use this one to just capture, maybe just take a photo of your whiteboard, and you don't have to manually write down the notes. You can just automatically extract the text, and that's really useful thing to have. And finally, computational photography. That's something that's deeply ingrained into camera software, into low-level software, so you don't even appreciate this one. So, but there's a lot of magic happening before you even see the image. So one example is HDR, high dynamic range image, where your camera basically takes multiple photos in different exposures and combines them in a really smart way so that you get a really nice contrast and nice imagery. And also here, like autofocus, where they basically do the thing I mentioned a couple of times throughout this presentation, that's semantic segmentation, and they figure out that there's a person in this photo, and they just blur everything around the person, but they don't blur the person itself. So you get these nice effects as if you maybe manipulate the depth of field or something that professional photographers know how to do, but it's hard for us mortals. But we have algorithms.